Bismillahirrahmanirrahim. Assalamu alaikum. Lecture number 11, unit number 8. The title of the unit is Functions and Graphs. In this video lecture, we will discuss the graphs of a non-linear function, that how we can plot or sketch the graphs of non-linear function. Before to discuss the graphs of non-linear function, in previous video lecture we discussed the graph of a function and the graph of a linear function. So I briefly revised that idea in previous video lecture. We discussed the graph of a function. In simple word, graph of every function, if it is linear, non-linear, is the set of the points, and when those set of points join together, we get a curve in two-dimensional plane if a function is single variable function. So here we know that we are discussing a single variable function, that is y is equal to f of x. So let's say this is an arbitrary function, a single variable. You see that x is in the argument, so it is a single input. So single variable function, so this is in general form a single variable function. So the graph of such functions is a curve in two-dimensional plane. Note the graph of y is equal to f of x is a curve in two-dimensional plane or xy plane, because the curve is actually set of points, and for each and every point of the plane you must have an ordered pair. And how you can construct that ordered pair? You need to give this x a value from the domain of the function, and you will get the value from given function that will be the value of y. So make an ordered pair from those values and plot that in the plane. So join those points in plane, you will get the curve of the given function. Okay, so in general, graph can be defined as in set builder notation denoted by G. Graph is actually a curve, and curve is actually set of points. So you see that, and for every point in two-dimensional plane you must have an ordered pair. So in graph there are ordered pairs xy such that y will be equal to f of x, where x belongs to domain of the given function f. If this x is from the domain, so the function will operate on the domain value. You will get a value in range, and when you make an ordered pair from that, and that ordered pair will be plotted, and all those ordered pairs are joined, so you will get a curve, and that curve must be the graph of that function. So this is the definition of the graph of a function. For example, you see that this is a two-dimensional plane. This is your x-axis, this is the y-axis, this is origin, and let's say you have a curve like this. Now you see that this is defined on this interval. So this is your domain. From this point to this point you have a domain. So these are the values of small f of x. Let's say this is the graph of y is equal to f of x. So when you plug a value from this domain, from this interval, let's say this is a and this is b. So this function is defined on the interval, closed interval ab. So when you plug a, you will get this point. So this point is actually a comma f of a. So this is your ordered pair. When you plug this point, so you will get, let's say this point is x and this point is, let's say, f of x. So this point will be, let's say x1, this is with f of x1. So this point will be x1, f of x1. F of x1 mean y1, let's say. So you see that when you give an input to the function, you will get a number in output. So when you take the ordered pair, make the ordered pair and plot, so that points will be the position, that points is actually associated with those ordered pairs. And when you make when you join all those ordered pairs, so you will get the graph of the function. So you see this curve, this is the graph of this function. Okay, but these inputs must be this x must be from this interval. You see that x belongs to closed interval ab, so this is the domain. So this is the graph of the function. So in other words, we can say that graph of the function is the set of the points in two-dimensional plane. Graph of the function is the set of the points in two-dimensional plane in which the first element of every ordered pair must be the domain of the function. So that is another definition for the graph of a function. Okay, so this is discussed in previous video lecture in detail. Now after that, in previous video lecture we discussed the graph of a linear function. If I consider a linear function in general form, linear function, so the general form of a linear function is f of x is equal to mx plus b. M is not equal to 0, because if m equal to 0, so that function will become a constant function. So this is the general form, and m and b are the constants. These are the constants. You see that m and b are the constants. Okay, so for example, if I take an example, f of x is equal to 2x plus, let's say, 2. So this is the given linear function. Here the value of m is 2 and the value of b is also 2. So how you can draw the graph of this function? So before to draw the graph of this function, you remember the shape of the graphs of the linear functions. So the general shape of the graph of all linear function is a straight line. So note that the graph of a linear function is always a straight line in two-dimensional plane or in xy plane. So how you can now, if you know the graph must be a straight line, so the minimum requirements to graph a linear function, to draw a straight line, actually is 2 points. So the minimum requirement for sketching the graph of a linear function, you need 2 points in a plane. So you need 2 ordered pairs. So how you will calculate those 2 ordered pairs? One of the method is to give a value to x from the domain. So domain is the set of real number. You will get a y value against that x, make an ordered pair, plot that, and pass a straight lines. But you need to at least plot 2 points in a plane, mean you need 2 ordered pairs. So you need to choose 2 values from the domain of the function and plug these values in the given linear function. You will get the values of y against those 2 values that you choose from the domain. So this is one of the method. Let's say let x is equal to 1. So this implies that y, when you put x is equal to 1 in this function, so against this one you will get value equal to 4. So the ordered pair is 1 4. Remember, the input value must be always first in the ordered pair. So you will get 1 ordered pair. How you can choose this x? How I choose that x is equal to 1? So this is the value from the domain. You may choose any value from the domain, and you clearly know that this is a linear function. So domain is the set of real number. This is the domain of this function. Now I am choosing x is equal to 2. So you will get y equal to 6. So another ordered pair is 2 6. Now just need to plot these 2 ordered pairs in xy plane and pass a straight line from those 2 points. Let's say this is x-axis, this is y-axis, and let's say this is 1, and let's say this is 4, this is 1. So this point is 1 4. Now let's say this point is 2, and let's say this point is 6. So this point is 2 6. So you get 2 points. You see that these 2 points in the xy plane. So just pass a straight line from these 2 points. You may also make more than 2 ordered pairs, but the minimum requirement for the straight line is 2 points. So you see that this is a straight line passing from these 2 points. So you see these 2 points lies on the graph of the linear function, mean lies on the straight line. So remember, whenever a point lies on the graph of the function, that point must satisfy the given function. So this is the graph of y is equal to f of x is equal to 2x plus 2. So this is one of the method. Now, but this method is not doesn't like looks as what you can say, this is not accurate. In other words, you can say, because you see that this line is passing from the y-axis at this point and from the x-axis at this point. So it will be better that you know exactly that from where the graph of the given linear function, mean the straight line pass from the x-axis and pass from the y-axis. So to calculate, to find the 2 points, mean the ordered pairs for 2 points, you need to find the ordered pairs for such points which are the x-intercept and y-intercept. So another method is find x-intercept and y-intercept. X-intercept mean the point on which the graph of the given linear function, mean a straight line passing from x-axis. So x-intercept, so the point which passes the point from which the straight line passing x-axis. So at that point the y coordinate must be 0, because this is a horizontal line. So for x-intercept, put y equal to 0 in the given function. So y equal to 0, so 0 is equal to 2x plus 2. So you will get x is equal to minus 1. So ordered pair minus 1, 0 is 1 ordered pair, mean point of the plane, and this point must be on the x-axis because you see that the y coordinate is 0, and this is the point from which the graph of this linear function, mean the straight line, will pass. So this is your x-intercept. And also find y-intercept because the minimum requirement for a straight line is 2 points. So for y-intercept you need to put x is equal to 0 because you know that this is the y-intercept, mean the point passing from the y-axis. So here the value of the x must be 0 because this is a horizontal line. So when x is equal to 0, so y is equal to 2. So y-intercept will be 0, 2. Clearly you see that this will be the y-intercept because the x coordinate is 0. So these are the two ordered pairs. So here this is x-axis, this is y-axis, and this is the point which is minus 1, 0, and this is the point which is 0, 2. So pass a straight line from these 2 points. So you see that you get the same line from here. This is also the graph. This is the same line as we constructed here. This is the graph of y is equal to f of x is equal to 2x plus 2. But this graph is more accurate than this because here this graph is also correct, but here there is a little ambiguity that the point at which the line passes from x-axis and y-axis is not mentioned. So that's why this is a little bit confusing. So that's why the better way is to draw the graph of a linear function. So you will find out the x-intercept and y-intercept and pass the straight line from those two intercepts. So you will get the graph of the linear function, which is a straight line. You may also make as many ordered pair as you want, but the minimum requirement is 2. So why you waste the time on the other ordered pairs? Okay. So this is the graph of the linear function. Now, before to discuss the graph of the nonlinear function, this is the standard form of the linear function where m equal to 0 and m and b are the constants. So its graph is a straight line. We discussed that in detail. Now, if b equal to 0, then this function become f of x is equal to mx. So this function is called homogeneous linear function. Now, if b is not equal to 0, so that functions are called non-homogeneous linear function. So if b equal to 0, so this is a homogeneous linear function. M may be any other, m may be 2, 3, 10, 20, but not equal to 0. So remember, the graph of the homogeneous linear function will also be a straight line because this is a linear function, but that linear function will always passes from the origin of two-dimensional plane, mean xy plane. So it means that the x-intercept and the y-intercept for homogeneous linear function is always 0, 0. So that is the point which must be noted here. I am taking an example. Y is equal to f of x is equal to, let's say, 4x. So you need to draw the graph of this function. So here the value of b is equal to 0. So this is a homogeneous linear function, and its graph will be a straight line always passing from the origin of xy plane. So this is an extra point that you must remember. That is x-intercept and y-intercept is the origin 0 0 of xy plane. So in this case you didn't need to find x-intercept and y-intercept to draw the graph of this homogeneous linear function, because it is obvious that if it is a homogeneous linear function, so x-intercept and y-intercept will be the origin, mean the straight line will always passes from the origin. This is an important point, because you see that for x-intercept you didn't do this, but I am just doing for your understanding. For x-intercept put y equal to 0. So y equal to 0, so for x equal to 0 implies that x is equal to 0. So you see that 0 0 is your x-intercept. For y-intercept put x is equal to 0. So when x equal to 0, so 0 multiplied by 4 you will get 0. So y implies that y equal to 0. So 0 0 you see that x-intercept and y-intercept is 0 0. So it means that the graph of the linear function which is homogeneous, mean the value of b in general form equal to 0, will always be a straight line, and that straight line will always be passing from the origin. Remember this point. This is an important point for eta. How you can plot the graph? Now y is equal to 4x is your function, is your given function. Now this is a linear function, so the domain is the set of real numbers. Domain is the set of real number. Here you just need one point, because one point is already, you know that 0 0 is the point from which the straight line will always pass, because this is a homogeneous linear function. So if this is your x-axis and this is your y-axis, so for the homogeneous linear functions 0 0 will always be the point which lies on the graph of the homogeneous linear function. So the minimum requirement here is you just need to make one adductor, mean you need one point in a plane. So that one point is there, and you make one point from here and join these 2 points, so you will get the graph, the minimum requirement. So how you can make a single, at least single, you may also construct A's, many A's you want, ordered pairs, but the minimum is here is 1, because 1 is already known. So how you can make that ordered pair? Just give a domain value from the set of real numbers to this function and calculate the value of y against that x. So let's say I'm choosing x is equal to, let's say I'm choosing x is equal to 1. So when x is equal to 1, so this implies that y equal to 4, so the ordered pair is 1 4. So you see that, let's say this is 1 2 3 4, 1 2 3 4. So this is 1 4, 1 and 4. So this is the point 1 4. So this is enough, but you want to find some other point also. So let's say I am choosing another points to make another ordered pair. So let x is equal to -1, because this is also in the domain. So you will get y equal to -4. So -1 -4. So this is your -1, 1 2 3 4. This is 1 2 3 4, and this is -1 -2 -3 and -4. Let's say this is your -1, so it will be so clear. So that point is -1 4. So you need to join these points, you need to pass a straight line from these points, so you will get the graph of the given function, the graph of the given linear function. So you see, this is the graph of y is equal to f of x is equal to 4x, where x belongs to R. So you see that this always passing from the straight line. Remember this point, from the origin, sorry. Okay, now if in journal form, if m become 1, so that and b equal to 0, so f of x is equal to x, so this is called identity function. Identity function, it is also a homogeneous linear function, so its graph will be also a straight line passing from the origin. You can see that I'm sharing a laptop screen with you to see the graph of identity function. You see, okay, I'm sharing a laptop screen with you. You clearly see that, this is the linear function. You see, identity function, let R be the set of real numbers, define the real valued function f from R to R, because the domain is also R and range is also R. Y is equal to f of x is equal to x. So this is the graph. You see that this graph is passing from the origin. This is the graph of the linear function, which is identity function, mean homogeneous linear function. So this is the graph. Clear? You see that this is passing from the origin, xy plane. Okay, now moving towards, if is f of x is equal to mx plus b, m not equal to 0, mb are constant. So this is a linear equation in general form. So we discussed the graph of this. If b equal to 0 and m is not equal to 0, so that become homogeneous linear function. We discussed that also. And if m become 1 and b equal to 0, so that become identity function. We also discussed that. Now if m equal to 0 and b is not equal to 0, so the given function y is equal to f of x will be equal to b, because m is 0, so 0 multiplied by x, so this is called constant function. Now this is not a linear function, this is a constant function. Constant function. So the graph of the constant function will be a horizontal straight line. Remember this point. Note the graph of a constant function y is equal to f of x is equal to b or c, but this b must be a constant, where b is constant, is always a horizontal, mean parallel to x-axis. Horizontal straight line. How? So I am taking an example. Y is equal to f of x is equal to, let's say, 2. So here the domain is the set of all real numbers, because by putting any value in the argument of the function you will always get 2. So 2 is defined for every input. So you may say set of real number is the domain. So if it is a horizontal straight line, so for that the minimum requirement is 2 point. Okay, so there per horizontal straight line the line will passes from the y axis. and never pass from the x-axis. So when I put x equal to 0, so y will be 2. You see that for any value of x, the y will be 2. For any value of x, the y will be 2. So make a table in this fashion. You put any value of x, the y value will be 2. Y will be always 2 because this is a constant function. It will not change. And you can give any value to x from the set of real number because the domain of this function is the set of real number. So for 0, the given function will be 2. If I put -2, so the function will be 2. If I put -1, the function will be 2. If I put 1, the function will be 2. If I put 2, the function will be 2. For any number, for any input, for any domain, the function will be 2, mean constant function. So the ordered pairs are in this case -2, 2, -1, 2, 0, 2, 1, 2, 2, 2. So if you plot these ordered pairs and pass a line, so that line will be a horizontal line, and that line will be 2 units away from the x-axis because y is equal to 2. So this is your x-axis, this is the x-axis, this is y-axis, this is 0, let's say this is 1, this is 2, let's say this is 3, this is 4, this is 5, -1, -2, -3, -4, -5, this is 1, and let's say this is 2. Now when you put 0, so you will get if you put -2, so you will get 2. So this is the point -2, 2. When you put -1, so you will get also 2. So this is the point -1, 2. When you put 0, so you will get 2. So that is the ordered pair 0, 2, mean the coordinates of this point is 0, 2. If you put 1, so you will get 1, 2. So the coordinate of this point is 1, 2. If you put 2, so you will get 2, 2. So the coordinate of this point is 2, 2. So pass a straight line from there. So that will be a straight line. I little mistakes, but it will be a straight line, horizontal straight line. You see. So this is a horizontal straight. So this is the graph of y is equal to 2. So if y is equal to 1, so the graph of y equal to 1 will be this. This will be the graph of y equal to 1. If let's say this is 3, so that will be the graph of y equal to 3. Let's say if this is equal to -1, so this will be the graph of y equal to -1. Let's say this is -10, so that will be the graph of y is equal to -10. So what will be the graph of y equal to 0? The x-axis. X-axis is the line on which everywhere y coordinate is 0. You see that if I choose this point, so the coordinate of this point is actually 1, 0. If I choose this point, so the coordinate of this point is actually 2, 0. So the graph of y equal to 0 is x-axis. And if I choose x is equal to 1, so that will be the graph of x is equal to 1. This vertical line. This is the graph of x is equal to 1. If I pass a vertical line from 3, so that will be the graph of x is equal to 3, because on this the values of the y anywhere is 0. The value of the x is anywhere is 3. If I this line, so this will be the graph of x is equal to -3, because anywhere on this line the value of x is -3. So the y-axis, it means that the graph of x equal to 0 is y-axis. So these are the two important points. Note the graph of y equal to 0 is x-axis and the graph of x equal to 0 is y-axis that you see it here. Okay, so these are the linear these are the graph of a constant function and the graph of a x-axis and y-axis. If I share a left of screen with you, so you will see. Now you see that you can see it here. Constant function, domain is also set of real number, range is also set of real number, but in this case the range is fixed because it is a constant function. You see, let's see, by putting any value in from the set of the domain you will always get C. So you see that range is only C. In the previous example we discussed if of x is equal to b, so the range is b. So you see that this is the graph of y is equal to 3, a horizontal straight line. You clearly see here f of x, you see here. Now you see it here, f of x is equal to 3. So this is the graph of a constant function. Now in next video lecture we will discuss the graph of the non-linear function, which is actually the graph of the quadratic function, which is the graph of the quadratic function and the graph of the cubic. So you see that this is the graph of the quadratic function y is equal to x square. This is a non-linear function because the power of the variable is 2. So u shape, parabolic shape. So we will discuss that in next video lecture inshallah. And then we will discuss the graph of y is equal to x cube. So you see that this is the graph of y is equal to x cube. Sorry, this is this one. This is the graph of y is equal to x cube. So this is also a non-linear function. So inshallah in next video lecture we will discuss the graph of non-linear function, which is the graph of y is equal to x square, mean the general shape of that is parabola, which is symmetric about y-axis, and then we will discuss the graph of x cube, and that graph is symmetric about the origin. So inshallah in coming video we will discuss. So in short, you must remember the shape of the graph of the given function. If you have a linear function, so the graph of every linear function must be a straight line. You must keep that shape, general shape in the mind. If the function is parabolic, mean if the function y is equal to x square, y is equal to x power 4, y is equal to x power 6, y is equal to x power 8, so all the graphs of these functions must be in U shape, parabolic form. This is the general shape, because graph is the infinite set of points which make the curve. So it is not possible that you can plot each and every point of the curve that make the graph of the given function. So that's why you must keep in mind the general shape of the graph of the given function. The shape is very important, that you know the general shape, and then you may plot 2 or 3 or 10 or 20, mean the points which you can plot, and then pass the graph from those points, keeping in mind the shape of the given function. So the shape of the given function, mean the shape of the graph of the given function, is so important while sketching the graph, because on hand you didn't plot each and every point in a plane which make the curve of that graph. It is actually calculated, it is actually sketched, draw with the help of computer. Inshallah in college we will discuss the method on computer also, that how you can draw the graphs. So in short, you must remember the general sketch, the general shape of the graph of the given function. Then it becomes so easy to draw the graph. Thank you.